Now today we will start with linked list. Now what linked list is, first we need to understand. We have studied about the composite data structures and we have stated that array and linked list are part of this composite data structure. Now array is a contiguous allocation of memory. Contiguous means one after another. That is, if we have the RAM over here, then the allocation over here, say suppose if we define int a5, then these 5 locations that will be allocated in the memory, for if we consider integer to be 2 bytes, then each of this is 1 byte. So this is for 0th index, this is for 1th index, this is for the 2nd index, and like that 0 to 4, that is 5 such indexes will be allocated for array. So this is what we have for contiguous allocation, that is one after another. But for non-contiguous allocation, what does non-contiguous means? Non-contiguous means it won't be one after another. I can keep one thing here, I can keep one thing another place, like that it can be kept, right? So this is the actual ordering that we find in the real life also. We can keep one thing one after another, or we can keep one thing here, one thing there, one thing any other place, right? So that is what is called a non-contiguous allocation. But in non-contiguous allocation, a sequence or a ordering has to be maintained. That is, we have to know that what comes after this very person is the very same thing. An example I will give it to you. Say suppose we go into say suppose this very doctor's appointment. Over there we write the name that this person will be the first one to go and get the checkup done. Then we have the second person, then we have the third person, like that all the names are written. Now the persons can, or the patient rather, can sit anywhere else. It's not necessary that they have to sit one after another, right? But they will be serviced in the manner that whatever is written in that very document, that who is the first one, that very person will be serviced first. Who is the second one, that very patient will be serviced first. Like that it will go on. So we have to know what comes after one after another. So for that very sequence maintaining, we have to consider the structure of the linked list. So we are keeping the things in a non-contiguous manner, that is not one after another, but we have to know the sequence in which the nodes are kept. That is, after this very data, what data should come. So I will just I have rather formulated the structure of the linked list, which is actually a self-referential structure. So type def struct linked list, obviously type def is for type definition. Struct linked list is the structure name, linked list is the structure name, within which we have stated what? We have stated a data part and a pointer part. Just look into here that there is a data part which is an integer and there is a point. So struct linked list star next. Star next is actually the pointer to the structured linked list, right? So it's a self-referential. Star next points to this type of structure only. So say suppose if we define node A and node B, so we have defined 2 nodes, right? So node is what? Node is the keyword, or rather the data type name that is that actually masks this whole struct linked list. So wherever we write node, it is actually struct linked list. So we are specifying struct linked list over here, but instead of writing struct linked list all the time, we can simply specify it with node, right? Struct linked list is actually node. So node A, this A is a node having 2 parts. One part is the data part and the other part is the next part. We have another node which is B over here. Now say suppose B also has the data part and the pointer part. So this is the data part and this is the next part. This particular node has an address which is 2000. Now this address can be held by the next part of A because A's next part can only point to the struct linked list type structure. So it can hold, say suppose if the address of A is 1000, it can point to itself also. So I can store over here 1000. So what type of address can this next part hold? It can hold the address of another structure. So over here B is another structure, A is another structure. I can make the address of B, which is 2000, get it stored over here at the next part, and this will point to this, right? So this is how it can be done. Now we have a linked list over here. I have just formulated a structure of a particular linked list. Over here we have 3 nodes, this one, and this one, having the address 1000, 2000 and 3000. So these are the address of the nodes, right? Just look at the last one. The last one points to null. Null means that it's the end of some this parsing. End of parsing, or simply this null indicates that pointer is pointing to nothing for now. Now head is what? Head is a pointer that points to this very first node. So what is the address of the first node? The address of the first node is 1000. So 1000 is held by head, right? Now our motive is what? Our motive is to get the values of 2, 3 and 4. So we want the values of this. For this very purpose, what we can do is we can take a separate pointer, and with the help of this pointer we can parse through whole of the list. Why do we take a separate pointer? We take a separate pointer because this head is actually pointing to the first node, and this is a unidirectional linked list. As this is a unidirectional linked list, it can move in only one direction, which is this direction, right? Now if this is the case, if we move the head to this location, then what will happen is we will lose this very node, right? So it's better that we take a separate pointer for parsing through the whole of the list. Now just how do we store the address 1000 over here, right? Over here what we can see is head is holding this 1000. First of all, how do we define this anyway? What type of address does it hold? Does it hold an integer address? Does it hold a character address? Does it hold a float address? What type of address is it holding? This queue is actually holding the address of the node, and the address that it's holding is a struct linked list type address or a node type address. As it is a node type address, so we have to define a pointer q which is actually pointing to a node type value or node type structure. So how do we do it? We simply write node star q. This will do the job. Node star q will create this very pointer which will point to the first location, but we need to make it point. So first we have defined this pointer which can point to any of a structure, or rather it can hold the address of a structure. Now I need to put this 1000 over here. For this very purpose, I simply write q is equal to head, right? This q equal to head, what will do is it will put 1000 over into q, and q will now point to this very first address. Now I can print the content of q, right? So I am printing the content of q. Print f mod d, right? Print f mod d. Now this mod d, why? Because we are printing the content which is an integer. And how do I print this? So this has two parts. One is the integer part and the other is a pointer part. If I want to use the integer part, as I have stated in the pointer to a structure or any such operations, over there we have looked into an operator which is this. So this is actually a replacement to our original usage of the structure using a pointer. So just simply think about it. If we normally used it, how will it go? Q is 1000. So this person Q is actually standing at 1000, right? Now if I want to enter the box, I have to associate a star with this person. So star of Q. The person has entered the box. Now there are two parts. One is this part and the other is this part. Which one to access? We access it with a dot. So we specify dot, and we want the data part. So we specify data. DATA. Now there is one problem. The dot operator and the star operator, over here star has less precedence while the dot has more precedence. So Q dot data will be performed first, then the star, but we do not want that. For that very purpose we give a bracket over here. So star of Q in bracket dot data, star of Q in bracket dot next. This can be done, right? But instead of using this, what we can do is we have a replacement for this, which is actually a arrow symbol. So we can replace this whole of this with a simple arrow symbol, which is Q arrow data, right? Now we have printed 2, which is fine. We have printed 2. We can give a comma or a hyphen over here. Hyphen will look nice. So 2 hyphen. But we want the content of this also. How do we reach here? Q is pointing to this. Now just think about it. What is this area contain and what does this area contain? This area is containing the null. This area is containing the address of this, which is 3000. This area is containing the address of this, which is actually 2000. So this is the current scenario or the current ordering in which the nodes are kept. Now, if I want Q to point to this, I have to store this address 2000 or this address 2000, both are same, then only it will point to this. How do I make Q point to this? Simply by getting this part and getting it stored over here. So Q will be equal to Q's next part. Just think about it. Q's data part is 2. Q's next part is what? 2000. So this Q's next part is actually getting stored into Q. And what will be this replaced with? It will be replaced with 2000. Now Q will be pointing to 2000, right? But think about it. We have to print this again and again change this Q to point it to here. So Q is equal to Q next will be performed. And this will keep on repeating. Say suppose we have 100 such elements, we will write this again and again, or we will enclose this whole of this into a loop. So the only difference between us and the computer is we get bored of performing the repetitive task, but the computer doesn't. So what we do is we enclose this whole of this 2 line into a loop. For here we have considered a while loop. So while Q not equal to null, this whole thing will be repeated. That is, Q was pointing to here and then it will point to this, then finally it will go to null. If we have such 100 such nodes, it will keep on passing through whole of the list until or unless it reaches the null. So while Q not equal to null, print the content Q data, Q's data, and Q equal to Q next, Q equal to Q next, so it will point to this. Q is equal to Q next, it will point to this. Q is equal to Q next, it will point to the next. So in this way it will pass through whole of the list, right? So this is how it is done. This is how a linked list is parsed.